Well, so welcome. So today we're looking at another module which is attacking what we do. Um, so our main objectives today is to explain how common network applications and services are vulnerable to attacks. And I think personally just explaining this is not enough, but also having another video that shows how we practically do this is going to be very, very informative and interesting and entertaining at the same time. So also look forward to my recording on most of the practical videos. So I'm planning to um, have those videos uploaded sometime soon. So I'm still in the process of just ensuring that I do what uh, I do the demos in a successful way, so that you can have the idea of how some of these attacks are performed end to end. Yeah, and that takes a little bit of some time, and that's why I did not have that as part of this, because if we're going to have the practical session, then this video is going to be too long, and I really don't want that. So I just want you to gather the content, and then later on now see how some of those things we've talked about are being done. Yeah, so we're going to explain the IP service vulnerabilities, and we're also going to explain how network application vulnerabilities enable network attacks. And we will begin by looking at IP services. At some point we'll look at DHCP, DNS. All these protocols are tied in one or the other. And so we look at the app vulnerabilities. I'm sure before we talked about the address resolution protocol and what it is. Yeah. So basically, in brief, the address resolution protocol, what it does, it's what powers communication between devices in a network. And there are two most important things, if I can just remind you, is that we need to have a MAC address and an IP address for us to have exchange of information between two devices in a network, or two nodes in a network. And so before a device talks to another device, of course each device in a network is identified by its IP address. So by the fact that host 1 has the IP address of host 2, doesn't mean that the IP address is enough for it to transmit data. So it also needs the MAC address for host 2. So it will ask and it will do a broadcast and ask ask for the certain IP to give its MAC address rather. So it will say, hey, host with this IP, what's your MAC address? Something of the sort. And then when the host whose IP address is in question gets to look at that message and identifies that that message belongs to that host will reply accordingly with the MAC address, and then later on it will be able to be part of the conversation or exchange of information for that matter. Yeah, so basically that's what happens, and I think that's what is happening. And so the goal is to associate the threat. A threat actor, how can a threat actor use the app to launch attacks? So this is what we call app cache poisoning, where the threat actor poisons the app cache of devices on the local network. So the app cache, maybe to remind you, is some memory that stores the pairing of the IP address and MAC addresses of the devices in a network. So by a device having that cache of paired IP and MAC addresses, it makes it so easy to to just initiate communication. It doesn't have to ask each and every other time for the MAC address, because it already has that within its cache. Yeah, because if each device was to ask each and every other time for the MAC address of the devices in the network, then you can imagine the amount of bandwidth that will be consumed and the kind of chaos that will exist. So the cache to some extent limits, improves, it gives us that ability of the devices to just broadcast once, and once they get the response, they save that. Next time they don't have to broadcast. Yeah, and it saves on bandwidth and a lot of things. So the goal is to, so the goal of address resolution, app cache poisoning by an attacker is so the threat actor's MAC address with the IP address of the default gateway. So what a threat actor does is, of course, the threat actor pairs his so he uses his IP, uses the legit host IP address as his IP address, but in real sense the MAC address is not of the legit host, but of the threat actor. So that means basically that the threat actor can use address resolution app cache poisoning to launch a man-in-the-middle attack, because if the MAC address belongs to the threat actor and the IP address belongs to a legit host, by the fact that the MAC address belongs to the threat actor, all communication will go through the threat actor before it is forwarded to the intended destination. Yeah. So and basically what happens there is when we have one host broadcasting into the network, so, and the message is like, hey, the owner of this IP, please give me your MAC address. What happens when we have a threat actor within the network? What happens is the threat actor will get that message because it is broadcasted to every node in the network. So when the threat actor gets all of that information, even before the intended host gets that information, the threat actor will reply quickly and say, hey, that IP belongs to me, and this is my MAC address. So the threat actor shares his MAC address instead of sharing the instead of us now having the MAC address of the intended host. And that's how you get that kind of pairing where the IP address of the intended host has been spoofed by the threat actor, and the MAC address of the threat actor now has been paired with the IP address of the legit host in the network. And then that means now that any communication between the host that was looking for the other pair of host to communicate then has the threat actor instead of the legit host, and now all communication gets to the threat actor. That's what's basically happened. Yeah, and that's how man-in-the-middle attack is executed. So, and that's exactly what is happening right here in this diagram. So you can see at the first diagram here, there's the app request. So we have this PCA that is, I don't know whether this one is clear to you, but we have PCA right here that is looking for the MAC address of 192.168.10.1, and we know that that IP address belongs to some router 1 here. So it's router 1 to reply with the MAC address. But then what happens? Yeah, so we see that so the app cache on the threat actor's host, we can see it has the correct pairing of the IP address and the MAC address of PCA, and then it also has the correct pairing of the router. Yeah, so it knows both. But then what happens then is that so you can see in the second diagram what happens is so instead of router 1 replying, router 1 is actually supposed to reply with its MAC address to reply back to hosts to PCA. That's supposed to be the legit reply, but that doesn't happen. Instead, what happens is now so I can see 10 dot, so the router has so if I see the MAC address here, the MAC address of the router is A1, 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 whatever. But so in the third image, you can see that router, the MAC address has been paired with the MAC address of the threat actor. That's what is happening, and that's not what's supposed to be the case. So all communication doesn't go directly to router 1, but goes through the threat actor because of the pairing. So exactly what we explained in the previous module. Yeah, so there are many tools that on the internet that one can use to launch address resolution protocol man in the middle attack. So sorry. Hi. Yes. Bado. Yeah, so there are so many tools that can be used to launch man in the middle attack. So we have a tool like Etacap, Kain and Abel, DNS Sniff, and Yasnia, and others. And I'll try to create a practical session that actually shows us how to use those tools to launch man in the middle attack. And then we have DNS attack. That DNS stands for domain name domain name system. So we have with DNS is quite an interesting topic because it's like at the heart of networking. What a DNS does is it enables you like to convert a human readable domain name like www.mydomain.com to an IP address. Yeah. So, and how does it do it? So within DNS you get that we have a number of things. We have a number of servers that helps in resolving the name or interpreting the name into an IP address. So we have what we call a DNS recursor, we have what we call a root name server, we have what we call a TLD name server, right? And we also have what we call an authoritative server. So maybe just to simplify things, and I'm doing this because I'm trying to remind you of something to do with DNS before we go ahead now and talk of the kind of attacks that can be executed against DNS. So for example, we have DNS recursor, which is in most cases is like when you visit a library. So let's assume that a DNS is DNS helps us to get information from a library, and the kind of information we're trying to get from the library here is actually the IP address that belongs to a certain domain name, right? So we go there, we ask the librarian, hey, I need this book, do you have this book? And the librarian, the function of the librarian is to go and get me the exact book that I'm looking for. If it's not there, then the librarian might advise, we don't have that resource here, but you can get it here. So something of the sort. So a DNS offers such kind of a service, but in this case now it gives us an IP address to a domain name, and it has all these kind of servers that I just mentioned that are aligned, and they help in resolving of the name step by step. So what happens at the recursor stage? At the recursor stage, quickly, the recursor is like the librarian who goes and handles the query now. So the user types something on the website, the domain name and whatnot, and the librarian is, the recursor is like the librarian that handles that query, is the one that has got first-hand information in regards to the kind of query that the user just entered onto the application, maybe using a web server, using a web browser, sorry. It can be via a command line, whatever. It can be even an application, a running application that wants to talk to some other application. And so it will look at the query, it will receive the query, and then it will do the request. It will send a number of requests to respective servers, right? And one of the immediate server that it will request information from is what you call the root name server. Yeah, and the root name server, so it's like the immediate server after the resolver, after the recurser, sorry. And what root name server does is it will try to translate, to make the first attempt of translating the human readable domain name into an IP address. So if we had a domain like let's say mydomain.com, so mydomain.com will be that bit that will be handled. My domain will be the bit that will be handled by the root name server. And then we have the what we call the .com. The .com section now is, if we don't get anything in relation to my domain, then we need to go all the way to what we call a top level domain. And the top level domain now is the .com, .org, and so on and so forth. So we have the TLD name servers, the top level domains that handle that section and point you accordingly. Yeah, so if we couldn't resolve my domain, we go now deeper, and we now handle the .com bit also. We assemble the two now, and we look for the exact domain that has and under the .com we look for my domain. So my domain in this case is whatever kind of domain that is of interest to you. Yeah, so that is it. And then we have the authoritative name server, and that now is the one that has the access to the requested resource. Yeah, so if in this case let's say in this case the recurser, the DNS recurser is the librarian, as we said, and then now we have the the root name server as let's say the root name server is the shelf. Now we have different shelves in a library. We have shelves for books that have to do with maybe computer science. We have another shelf that has to do with books another shelf that has history related books, another one that has books related to something else, mathematics, and so on and so forth. So that kind of grouping, you can say that is under the root name server now has that kind of grouping. It can tell you, okay, you're looking for your domain belongs to, for example, mathematics. Yeah, so go to the mathematics shelf. And then under the mathematics shelf, we have so many books to do with mathematics. So we have, for example, we have books to do with, let's say, statistics. We have other books to do with pure mathematics. We have other books to do with algebra. Yeah. So the TLD now is the one that handles now the specifics within the shelf. So which row? Yeah. So the first row has to do with statistics. So the TLD, like let's say now that is the .com, and another row has to do with .org. So the TLD now will point you accordingly based on the query that we got from the user. So did the user domain have .com? Yes, go to this row of this shelf. And then we have the authoritative now. Authoritative now will say, okay, so it was on not just on this shelf, but also on this column of the shelf, or on this row of the shelf. So which exactly is the book? So the authoritative name server now will go exactly and pick the exact IP address. Now, in this case, the exact book that the user was looking for. So that's how the DNS works. I mean, a lot of word there, but I mean, it was nice to break it down and show you that within DNS we have quite a number of servers that handle different things. When you enter that domain, it is broken down, and how it is searched, it is entirely based on the four major domain servers I've just mentioned. And so what are some of the so resolving is just like when you're talking of resolving, we're just talking of translating now. Yeah, translating the name into the IP. Yeah, so and the whole of that process that we just mentioned. So we have some of the attacks that can be launched based on that. We have the DNS cache poisoning attacks, and what happens is that the threat actors will just send spoofed or falsified record resource, what we call RR information, to a DNS resolver to redirect users from legitimate sites. And then we also have DNS amplification and reflection attacks, and I think we looked at that some time back, where threat actors send DNS messages to the open resolver using the IP addresses of the target. So the target ends up getting lots of responses that did not originate from the target, but they originated from the threat actor. And I think also we also have DNS resource utilization, because some of these DNS attacks are good examples of denial of service attack, which consume lots of the DNS resources, server resources, and that results at the end of the day making it impossible for other nodes to access the DNS, which results to DOS, denial of service attack. And then we have DNS stealth attacks. So threat actors most of the times would want to hide their identity. And the best way to do that is through DNS stealth attacks, and that has got a number of techniques like fast flags. So fast flags, this is kind of a technique where the threat actor will hide their phishing and malware delivery sites. Yeah, so you'll not be able to tell whether the kind of site, the domain that you're seeing is actually a phishing, or you won't be able to tell whether it's a phishing or a malware site, delivery site, because the name of that site keeps on changing very fast. It's the same site that is delivering malware, but it keeps on changing very fast. So those are kind of sites that are used to deliver payloads from the attacker to the target, right? And so to ensure that the target doesn't get to notice this, the domain name keeps on changing over and over. Otherwise, if it remains consistent, it becomes so easy to capture that using the intrusion detection system and intrusion prevention system. Yeah, so even the DNS IP addresses also keep on changing continuously. And then we have what we call double IP flags. And what happens here is that the attacker will change quickly will change the host name to IP address mapping, and to also change the authoritative name server. Yeah, and that increases the difficulty of identifying the source of the attack. At the same time, we have the domain generation algorithms that are able to generate random strings of domain names. So if you also are able to capture some unique, some weird domain names that have been randomly generated with letters and whatnot that cannot even be read, with long strings, then most probably those ones were generated by the domain generation algorithms. And that also makes it difficult to track such kind of domains, because at the end of the day, you don't really get to find where they originated from or to investigate them. Yeah, so we also have what we call DNS domain shadowing attacks. So in domain shadowing or threat actor, in domain shadowing, what a threat actor does is so threat actors gather domain account credentials so as to go ahead later on and create multiple subdomains which they will use during their attacks. Yeah, so basically you get that if your domain was mydomain.com, so the attacker will collect a lot of information about that domain and create some other subdomains like print.mysubdomain.com, mail.my, and so on and so forth, which you did not create. So it's always nice to check to ensure that you don't have subdomains that you did not create, and that happens when someone steals your domain account credentials. And so this is what most attackers do. They create some subdomains and then use those subdomains to deliver payload and so on and so forth. And then we have so those subdomains don't point to the legit servers. They always communicate with the command and control center of the attacker. And then we have DNS tunneling, which I'll just briefly say it is a form of stealing data using DNS, because most of the times we don't in most networks we don't so highly guard DNS like we do other protocols. So with other protocols we enforce kind of tight security for those, but with DNS, because of its nature, it was built without a lot of security consideration, and that also has its advantages, because if we had to enforce security to the fullest with the DNS protocol, then most probably we will crumple some of the internet services. And so for that matter, the disadvantage being security, but I mean that disadvantage in some ways an advantage in terms of ensuring that some of the internet services are up and running more efficiently, maybe fast, and so on and so forth. Yeah, so because of that that less of a security implementation in DNS, you get that threat actors go ahead to use DNS to exfiltrate or exfiltrate data from companies of interest or targets of interest, or deliver payloads that will be used to escalate other attacks or to launch other attacks. Yeah, so DNS in itself has got different types of records. We have different types of DNS records. You have TXT, MX, SRV, null, and so on and so forth. Maybe in future we'll break down the DNS, but I don't know whether we looked at it before, but I'll check and see. If not, I'll also upload a video on the same. So these records have different, they carry different sort of header information, and at times, for example, the most commonly used is the TXT, where an attacker can use the extra space maybe to inject some payload and whatnot. Yeah, so I think this deserves its special video, and we will try as much as possible to demonstrate how that happens. So to stop DNS tunneling, we need to inspect our DNS traffic. We have to filter and inspect our DNS traffic, and that's not easy, but it can be done. Maybe also encrypt our traffic, because if we encrypt our traffic, then and also even the encryption itself can also be used by the bad guys, because they'll just encrypt bad traffic and get it in again. So it's so tricky. So because we're trying to stop them from stealing data from the target, or delivering malware to the target using DNS. And so DNS inspection is the most important thing that can be done. Yeah. And then we have a dynamic host configuration protocol, and what DHCP is, it's a server that dynamically gives clients IP addresses, and it can also be abused. So what the DHCP does is, when the client wants to join the network, what the client does is broadcast and says, hey, I need an IP address, and the DHCP will, when that gets to the DHCP server, the DHCP server will respond and say, okay, I have this IP address within the pool. I still have this number of I still have this IP address that is free. You can use this one, and if there is none, then it will just reject that request, because there is no IP to be issued. But if it is, then it will respond by saying, I have this IP address, but it will not be a broadcast, it will be a unicast. So there's a difference between broadcast message goes to everyone, and then unicast message is directed to a particular client in the network or node. So the DHCP will respond with the unicast message, which is directly targeted to, which is directed to the client that requested, and then the client will of course will also respond back and say, I have accepted the offer, and of course the DHCP again will respond and say that acknowledged. So what are some of the weaknesses that can come with that? We have what we call DHCP spoofing attack. And how does it happen? It happens when we have an introduction of a rogue DHCP server that is also part of the network. So we have a legit DHCP server and we have a rogue DHCP server, and when a client requests for an IP address, instead of the DHCP, the legit DHCP server responding with the IP address, you get that if that communication gets to the rogue DHCP server first, then you get the DHCP server issues an IP address that will ensure that the client communicates to the rogue DHCP server instead of the legit DHCP server. So a rogue server can provide a variety of misleading information, and one of the misleading information would be a wrong default gateway. Yeah, so all the communication of the client will be channeled through the wrong default gateway, and that is a sort of a man in the middle attack. Or it can the rogue DHCP server can also give a wrong DNS server, that is the domain name server, and if that happens, then that means that so the server addressing point, so this will always be redirected to a malicious website. Yeah, and therefore they might end up even downloading more malicious payload and so on and so forth. Yeah, and lastly, of course, get a wrong IP address that it wasn't intended to, or the client wasn't supposed to get. Yeah, yeah. So it can be a client can get a wrong IP address, or can get both wrong IP address and a wrong default gateway, or either, and so on and so forth. Yes, so we will have a lab on capturing DNS traffic, and we'll see how you can poison the DNS and so on and so forth. Hope to upload that soon. So we have enterprise services, and some of the enterprise services that are common everywhere is using web services, and that means using HTTP and HTTPS protocols. So how do we investigate web-based attacks? Yeah. So so if you have to investigate web-based attacks, that means you have to have an understanding of HTTP and HTTPS protocols, and those are protocols that we use, that web services use to talk to one another. Yeah, we at some point we mentioned the HTTP methods, the 100, the 200, the 300, the 400, and the 500, and the meaning behind those ranges of messages. So 100 is just informational, 200 that means there is something is okay, whether a resource has been created or it's just an okay. Yeah, we had 300 which actually stood for redirection. Yeah, so sorry about that. So we had like 300 which actually meant redirection, and then we have 400 which means that the resource was not found, or there's resource not found error, and then 500 which basically means that we have a server error, and in there we have like 201, 200, 202. Yeah, which, so this is just general, but when you boil down to 201, 202, and so on and so forth, those ones give specific messages based on the error, the domain information. If it's just informational, if it's okay or successful, as 200 suggests, but we have 201 which means maybe a resource was created successfully, 200 which just means it's okay, and so on and so forth. So you also need to be able to dig down and get specifics of the HTTP methods messages. Well, so that's to do with the HTTP messages and some of the common stages of a typical web attack. We have the victim. Most of the victims unknowingly visit sites. Yeah, so you given you're doing your browsing and you get a link to a certain site that suggests that that link suggests that that's actually the resource that you're looking for, and then you unknowingly you click, and not knowing you end up downloading malware on your PC, and that gets your PC gets infected and so on and so forth. So that's number one, how people get attacked while using these protocols. Number two is you access some sites that are already compromised. Yeah, compromised web pages, which redirect you now to now malicious, the real malicious site that contains the malicious code, and the rest is history. And then we have the user visits sites with malicious code, and their computer becomes infected. So we have so many sites that you can't go without. We have so many sites that have malicious code, and it's open knowledge. So sometimes the user just takes the risk and goes and visits those sites. Maybe it might be these pirating sites where you download softwares and whatnot, and you download software that is already compromised, and there you go. Yeah, because you like free stuff. And then after another way that users get attacked is yeah, so I mean, those are some of the examples. And once you download the malware, the next thing that you get is the malware gets executed on your PC. It connects to some control and command center of the threat actor or the bad guy, and the rest follows. So if it was that attack was meant to gather information from your end, then that takes place. And so many other things that I can't even imagine of. Yeah, so these are some of the HTTP methods we talked about, and yeah, it's good because if you're having lots of redirection, then that means there's something going on. So you need to really investigate that when you are, especially when you're capturing HTTP and HTTPS traffic, and you have lots of redirection. You really need to dig down and see where you're being redirected to, right? Maybe you need to blacklist some of those domains that you're being redirected to, which should be malicious, because the link you clicked isn't really the one that you end up landing on. Instead you behind the scenes you are redirected to some other site. So yeah, so redirection is the most important here. The rest, I think, don't really give us much of a worry in terms of investigation at this point. Yeah, but it's good to know. And then how do you defend against web-based attacks? Number one, always update the operating system and the browser with the current patches and updates. You can use what we call a web proxy server that is able to introduce some layer of security between you and the internet, so that you don't end up releasing sensitive information to the internet, number one, because it can introduce a layer of encryption, or you don't end up accessing bad sites because the proxy server has like a knowledge base of the bad sites, and it's up to date. So if it's up to date, so it will be able to help you block access to some of those malicious sites. And a proxy server can do a lot of things. It can do caching to ensure that you easily access some of the sites you need, and so on and so forth. But in this case, you're talking of it securing you from accessing bad sites and downloading bad malware onto your site. So proxy server does quite a lot of things. So there's another, you can use the best security practices. We have what we call OWASP. It gives us like the 10 most vulnerabilities that exist on the web, but also gives you recommendations on how to handle those vulnerabilities. So you can always check, you can always run your application against the OWASP top 10. And then we have, of course, if you're in an organization or elsewhere where users heavily rely on the web services, you can educate them on how best to use the web services and avoid the web-based attacks. So we have common HTTP exploits. Some of the common HTTP exploits, of course, we have the malicious iframe. You can embed another website within a web page, and that is possible by use of iframes. But then at most of the times you get that the iframes get abused by attackers. So what attackers do, they'll insert advertisements to other sources into the page. So when you click onto those advertisements, it takes you now to their site, the malicious sites, where you end up downloading bad stuff that you did not need. So iframes can basically be used by malicious guys, by bad threat actors. Bad guys can be used to deliver malicious exploits, such as spam advertising, exploit kits, malware, and so on and so forth. So how do we prevent that or reduce malicious use of iframes? Number one, of course, we mentioned the use of web proxy, and then we can also ensure that the web developers do not use iframes at all on the sites that we consider sensitive, and then use services such as we have a Cisco umbrella that can use to monitor and block bad sites. So it prevents users from navigating to malicious sites, and then we can ensure that end users understand what an iframe is. They should be knowledgeable about that. And then we mentioned the HTTP method 300, which is redirect. So which most threat actors use. They use 302 found HTTP response status code to redirect the user's web browser. So this is something that you should be able to investigate when you see it. So in most cases, the browser is invited to request this new URL. So the URL, so if you click a URL, the user is given another URL that is pointed to, and that most of the times that they are redirected to sites that are malicious. So how do you prevent or reduce the 302 cushioning attacks? We call it 302 HTTP 302 cushioning attacks. We use a web proxy to block malicious sites. I mentioned web proxy before. I'm not going to talk about it, or the Cisco umbrella for that case, to prevent users from navigating to those sites. And we can also inform the user, let them know what 302 is. Right, so we also have what we call domain shadowing. So, and what happens here is a threat actor will create a domain shadowing attack, to compromise the main domain, and then therefore they will end up also creating multiple domains of that same domain, which the user, so this will basically redirect the user to the malicious site instead of to the real site. So you get a site that almost looks similar to your site. So if if I have a site, a domain name called mydomain.com, you get that the threat actor also creates another domain. Instead of mydomain.com with the one Y, it has my with double Y, for example, and most users will not easily recognize that. And so and it looks similar. The website looks similar to the other one, so it's not easy if you don't have attention. If the users lack attention to details, then most probably they'll end up feeding their sensitive data if that was the case, to a wrong site, which whose main purpose was to actually gather that kind of data and use it against the target. So how do you prevent? Steps to prevent, to reduce domain shadowing attacks: secure all domain owner accounts, ensure that their domain owner accounts are not hacked, and because the only way that the shadow account domains can be created is if the attackers have some of the domain credentials and whatnot, which will allow them to create some subdomains and whatnot. Use a proxy server, use a service such as Cisco Umbrella, and then make sure that domain owners validate their registration accounts over and over. Yeah. So if you're a domain owner, most of the times you get that the domain service provider asks you to update your domain information to first of all verify if that information is yours and if it is correct. Yeah. Emails. Yeah, so attacks can also be launched via email, and that is very very common nowadays. So yeah, so users can access email. So in most organizations can't survive without emails. Like, I mean, email is like one of the core tools that's being used for communication within an organization. So we have a number of email attacks. We have attachment-based attacks. You get an attachment within your email, and that attachment has an malware embedded in it. So when you download the attachment, you get to download the malware on your end, and that's how you launch chaos. You execute chaos on your PC or in your network. Right. So there's attachment-based attacks. There's what we call email spoofing. This is kind of a targeted attack. So an email is sent to specific individuals with forged addresses. So those addresses are not real, but they are forged. Yeah, and most of the times they'll have to do with asking for money and so on and so forth. And then we have spam emails. These are emails that are randomly sent to you, emails you never expected. The end user, the receiver did not expect, so it's just receiving emails from random sources. Some have some to do with what the user or the end user doesn't even consume, right? But some of those emails might be interesting to the user. And if, for example, if you're a football fan, you get an email to do with football and stuff, and then you click it, the next thing is you are on a malicious site, and the rest is history. Yeah, and then we have these open mail relay servers. Most of the times developers like myself use those to test our email service when you're developing some sort of email-based service in our application. So we use those instead of maybe Gmail and so on and so forth. And sometimes those open mail relay servers might be misused by the threat actors to deliver email to people. Yeah, and some people reply to those. So you should be able to tell. So users should be trained to know emails that are coming from well-known email relay servers like Google and Hotmail, Yahoo, and the rest should be questioned. Yeah. So we also have web exposed databases. Yeah, we know that when you have a web application service, you'll have to connect it to some database service somewhere. So most of the relational databases often contain sensitive data that most of the threat actors always look for. And some of the attacks that threat actors would launch against the database will be attacks like code injection and SQL injection. And what's code injection? So these are topics on their own. When you have to do a lab on this, they are quite extensive labs, or just demonstrate how you can do a SQL injection or code injection in a database and be able to extract data from a database. So the attackers, so in code injection, what attackers do is they execute commands through a web application. Yeah, like you have that login form, can use the login form to basically talk to the database by using specific commands. So so how does this when do we have success when someone uses this kind of attack called code injection? That only is possible if the user did not, the engineer or the programmer did not implement what we call sufficient validation of user input. So but if the programmer enforced validation of user input, then most of those commands will fail at the point where the user input is being validated, both at the client side and at the server side. And then we also have the SQL injection. And what SQL injection is, threat actors basically use SQL queries to talk to the database, so and obtain sensitive data. So so by use of SQL queries, so SQL queries, this is the language that the database understands. So the attacker can connect to a database via the command line or SSH, and then once the connection is successful, can go ahead. It might be whether it is successful or not, for as long as the attacker has knows where the database is and can at least prompt the database in one or the other, even without the some of the access privileges that they need to extract some kind of information from the database. They'll still be able to use the SQL queries to extract information, what we call SQL injection, to talk to the database and get information. Yes, so those queries are quite advanced and complex, so this is also another topic on its own. And then we have what we call cross client side scripting. And to summarize, this is the threat actors will use languages that web-based languages, of course, like JavaScript, Visual Basic. These are scripting languages, so they write scripts on the front end that on the client side that are used to inject malicious scripts, of course, that will do something for them. Either they'll download malware or they'll steal information from the client. So these scripts are malicious scripts embedded on the web application or on the web page, and then when the user clicks any of the link that when the user clicks and launches any of these scripts, then they get to launch malware on their side, and maybe if the intention was to extract information from the client from the target device, then that takes place. So there are two main types of cross-site scripting, and we have what we call stored, which is persistent, or reflected, which is non-persistent. So stored and reflected, or persistent and non-persistent. Well, so how do we prevent the cross-site scripting attacks? Number one, we have to ensure that web application developers are aware of what cross-site scripting is and the vulnerabilities that come with it, and also avoid that. Number two, we can use the intrusion prevention systems to detect and prevent malicious scripts if they do exist. So the IPS can be able to scan some of those websites and web pages, web applications, to see if they contain some malicious scripts. And then we can use web proxy, of course, to block the malicious sites, and we can also use services like Cisco Umbrella, as we mentioned before. And we will have database a practical session for this. Maybe just to cut more or less, these are Linux based commands that we can use to look at the logs, because when you're doing forensic investigation to tell whether we have been attacked or not, or there's an attack going on, we basically go through the logs, and we can use the cat more or less commands to sieve through the log files. So the cat more or less kinda the more of paging kind of commands, because if you just say cut this log file, it gives you like everything within that log file. If you say more, it's more and less are more of paging like commands, so they give you section by section of the whole log file. And then you have log files and syslog. So syslog is like so that's like let me say like the engine that collects all the system logs, all the logging information that is taking place. Yeah, and general CTL is like I think an interface that we use to easily query the log the log files accumulated by the syslog. Yeah, so basically that is it, but it's nice to know how to use those. Yeah, so basically that is it for today. So maybe we look forward to a practical session, and I'll try as much as possible. I badly want to do this. I want to do these practical sessions. The only thing is the time it takes to do it end to end. It's not the easiest bit, like just going through the theory. Yeah, but it's the most important thing. So I'll take time to set up one, then we see how it goes. Till next time, I just want to say thank you for taking your time to go through this content. Thank you. And with the interruptions along the way, sorry about that. I hope to create a favorable environment next time. Yeah, apologies. Okay, have a good time.